The first section of the textbook talks about layers of the earth, and the second section talks about heat transfer. And at first that may seem odd, but it turns out heat transfer is very important in the earth. If you think about the earth, there is differences in temperature. At the surface of the earth, it is cooler, and as you get deeper into the earth, it gets hotter. And heat is transferred through the earth, so that's why we're going to study heat transfer. You can see that this picture shows the three types of heat transfer. There is convection, there is conduction, and there is also radiation. All three of these allow heat to travel from one place to another. It's just that all three have heat traveling different ways or being transferred different ways. So let's first talk about what heat transfer is. One of the things that you need to know is that heat always moves from hot to cold. Always that direction, never cold to hot. Always heat moves from hot to cold. A different way to think of cold is that cold is simply just the absence of heat. You can almost say cold doesn't exist. You just have different degrees of heat. If you have a lot of heat, something is warm. If you do not have a lot of heat, something feels cool. And again, there are three ways that heat moves from where there is a higher heat amount to where there is a lower heat amount. By the way, you'll see this little GIF. That's because a lot of people are kind of surprised by that concept to think that perhaps there is no such thing as cold, more just the absence of heat. So one of the first ways that heat can transfer is through something called radiation. And this is the one kind of heat transfer that does not need any contact whatsoever. Heat travels through empty space, no need for objects to touch. So the sun heats the surface of the earth through radiation. The sun does not have to come into direct contact or anything like that. Obviously, that would be bad. So radiation travels through space. Here, if you're around an open flame and you can feel the heat from the fire, that heat is traveling through space to get to you. So that is also an example of radiation. Conduction is where heat is transferred, but the materials have to be touching in this case. And if you look at this picture, right, we know that the outer core is super, super hot. So the part of the lower mantle that touches the outer core, heat is transferred from one layer to another by touching. So that's one way that heat is transferred inside of the earth. And then we also have convection, and we'll talk more about convection later, but convection is when heat travels through a fluid. Now, in science, fluids are considered liquid or gases. You have talked a lot about convection in gases, right? You've talked about hot air rising, cool air sinking in the past. Technically, a gas is a fluid. And we're going to focus on this happening in liquids, but it's the same idea as hot air and cold air, that here we have some sort of a heat source, and then we have a fluid sitting on top. And the fluid that's close to the heat source warms, and that's represented by these red arrows, and then it rises up. And then when it gets farther from the heat source, it cools, which is represented by these blue arrows, and then it sinks to where it gets close to the heat source again, and then we begin this cycle. And that is a convection current. Now, there's also something to do with density in here, that hot materials are less dense, so they rise. Cool materials are more dense, so they sink. And gravity also helps with this. So convection happens in the earth, particularly in two layers. And we're going to be talking more about these layers in the next section. But convection currents exist in this layer in the mantle called the asthenosphere. So the part of the asthenosphere that is closer to the core is hot. And then the hot material rises, but when it gets farther away from the core, it cools and then it begins to sink again. And so you can see these convection currents inside of the asthenosphere. These convection currents that are inside of the asthenosphere, we're going to find out that they're what's responsible for moving the surface of the earth around. We're going to learn that there are these things called plates that sit on these convection currents right here. And they just travel with whatever way that convection current is going. And so we have plates that are sometimes colliding into one another, and we get earthquakes. In some places, they're separating from one another. In some plates are slipping past each other. And we'll be learning all about that. There are also convection currents inside of the outer core. And this is liquid metal that right down here towards the inner core, it's super hot. Hot material rises. It gets farther away, and then it cools, and then it sinks. And they believe that it's these convection currents that generate Earth's magnetic field. Now, if the inside of the Earth cooled off and we didn't have this temperature difference, there would not be convection currents. Convection currents only occur when we have difference in temperature. And we do. Hot and then cool. So that's a difference in temperature. So we're going to have convection currents. It's important that you know that a convection current, there are three things that need to combine in order to get a convection current in motion. One, and we've talked about this, you need to have a heating and cooling of the fluid. So we have a heat source. So we have a place down here where the fluid can get hot, and then it rises, and when it gets farther away, it will cool, and then it will sink. So we have differences in temperatures, another way to talk about this factor. Heating and cooling of the fluid, or differences in temperature in the fluid. We also need changes in density. Now that happens automatically because as something heats, it becomes less dense and will go up. And when something cools, it becomes more dense and it will sink. Now we also need gravity to help out here, right? Because we need gravity to help pull this cool material back to the heat source. Now, I've been sitting here talking about density, and I think it's nice to kind of have a little bit more of a visual of that. And so here you can see that I have these particles, and these just represent the liquid particles inside of the fluid that is sinking back to the heat source. So this fluid got cool, remember, because it got farther away from the heat source. So the particles became more dense. They squeezed closer together. And again, when you're more dense, you will sink. And of course, gravity helps pull these dense particles down. But over here, when you get closer to the heat source, the fluid gets hot. Now, when they do that, the particles will spread farther apart. And you can see here that these particles are spread further apart than they are over here. This causes them to be less dense, and less dense things rise. And here is a picture of convection currents inside of the mantle. These convection currents inside of the mantle move the lithosphere around. Now, just as a little practice, let's look at these. And so let's see, can you look at this first picture and guess what type of heat transfer this is? This person is sitting by an open flame and they are getting warm. If you said radiation, you are correct. Here we have looks like he has something and he's putting it into the fire. It says that poker's too hot to hold with my bare hands. So which type of radiation would this be? If you said conduction, you were correct. Conduction is why if you sit a metal spoon in a pot of boiling water, the spoon will get hot because it conducts the heat. And through touching the hot liquid, the metal spoon heats up. Now, we also know there are some substances, by the way, that are very poor conductors of heat. Wood is one of them, so that's why we'll often use a wooden spoon, because even though it's touching the hot liquid, it won't heat up because it doesn't conduct. And so here we have one where it says, I'll turn on the fan, all the warmest air is up near the ceiling. So warm air rose, what type of heat transfer would this be? If you guessed convection, you are correct.